Hello everyone. Today we're going to talk about Physics 253, Week 5, problem number 25.17. In this problem, we are tasked with finding the potential difference that a proton must be accelerated to reach the same speed that it would by falling 200 meters in a vacuum. So to start off this problem, I've gone ahead and drawn two pictures. However, I don't think they help us too much for the actual calculations. So here we have a proton in our accelerator. Let's just say that this is the LHC. And here we have our proton in a falling vacuum here. Our vacuum that is falling. And we have our distance of 200 meters here. So really in this problem, we're just working with energy, similar to everything that we have really talked about in this chapter. Specifically, I'm going to be using sources from, I think it's 25.4 in our e-text, has a lot of information about at least our electric potential, which is helpful for this problem because the potential difference that the problem is talking about here is actually our difference in the electric potential, and we know this by in our box of Mastering Physics, the final answer is given as delta V, which is going to be the difference in electric potential. So starting off with the problem here, we need to involve height in this problem. So if we remember back to Physics 252, we have an equation for the potential gravitational energy, which is UG, or mass times acceleration, or gravity, times height. And we also know that our potential kinetic energy is defined as 1/2 mass times velocity squared. So then from our 25.4 chapter in e-text, we also know that the electric field potential energy is defined as U equals Q times V, where V is the electric potential. And we also are going to need our mass of a proton because we are dealing with protons in this problem and not electrons. So to start off the problem, we can go ahead and say that we're working with two systems here. So we can say that we have one system that is the vacuum, and we can say that we have one system that is the accelerator. So in our case, in the vacuum, we have that the gravitational potential energy is equal to the kinetic energy, because this is a closed system. And what we can do is we can just say, okay, K is equal to mgh, and we can plug in our values for mgh here. And then we can use this K for our accelerator, our kinetic energy for our accelerator. And this is going to be in joules, of course, since we're talking about energy. So now here in our accelerator, we have our electric potential, and our electric field potential, and we can set this equal to our kinetic energy, and we can define our electric field potential as our charge multiplied by our electric potential, and we can just solve for the electric potential. And in our case, again, since we're working with protons, we use the proton charge here, and we just plug it into our equation, and we get 2.04 times 10 to the -5 volts. So I hope you guys found this video helpful, and thank you very much for watching. Have a great rest of your week.